Yes, hi again. This is George Lerakis from Montreal Math and Physics Tutoring, and today I would like to discuss about how to use Kirchhoff's rules to solve problems. So I know a lot of students they have difficulty using these rules for mainly three reasons. First is that they find difficult to use the first rule because they don't know which junction to use, and also they don't know what direction the currents should have. The second reason is because of the loops, which means that they don't know which loops to use. And the third reason is they don't know how to apply the second rule of Kirchhoff, which has to do with the voltage, because they don't know what quantities to put on the one hand side of the equation and what on the other, and which one should be positive and which one will be negative. I mean, you don't have to worry for any of these three problems, because for A, actually you can use any junction, doesn't matter which one you will use, and also you can arbitrarily assume the direction of the current, and if you choose the wrong direction, at the end of the problem you will get a negative value. So that means that the value is correct, but the direction of that current it's the opposite from the one which you assumed. So that's for problem A. So now from problem B, which loops you should use? You should always use the loops that they don't contain any other loops inside them. And for the third problem, like the Kirchhoff's voltage rule, I use as a substitute to this rule the Ohm's law. So that means that on the one hand side of the equation I take the sum of the voltages, and on the other hand side I take the drop in the resistors that happens in the circuit. Now, let's state the brief theory. So the brief theory for this topic is, the two rules of Kirchhoff's. So the first is the junction rule, which says that the sum of the current that they come into a junction has to be equal with the sum of the current that goes out of the junction. And the second rule is the loop rule, which says that the sum of the difference of the voltage across a closed loop has to be equal with 0. So now let's do a problem. So we have this circuit here, where you have that this here is 70 volt, this here is 60 volt, and this is 80 volt, and we have also that this resistor is 4, this here is 3, and this here is 2. So the question here is to find the currents I1, I2, and I3. So what do we do? Let's say we start first from the Kirchhoff's second law, which has to do with the drop of the voltage. And to show you about the loops, which loops I use, there are actually here two loops that you can use. Is this here and this here. Now, if you take also the whole thing, which includes the two loops, it will not hurt, but you won't get any additional information, because when you do that, you will get the linear combination of what you will get from the equations that you will get from the two first loops. So let's first take this loop here. So what I do, I use Ohm's law, and on the left hand side I put the voltage, and on the right hand side I put the drop in the drop of voltage through the resistors. So I mean, since this goes, if this voltage here goes like this and this goes like this, but this is arithmetically greater than this, so I use 70 minus 60, and so that means that I assume that the direction of the loop is like this. So that means that it should be equal with 3I3 and plus 2I2, because I assume that this goes like this, the I2 goes like this, so all of them, they are in the direction of the loop. So that's the first equation. So now I go to the second loop. So I mean, with the same logic, this here is 80, this is 60, so I take 80 minus 60. So that means that now the direction of the loop is like this. So that means that this will be equal with 4I1 and plus 3I3, because both this and this, they go with the direction of the loop. So of course, I get one more equation from the junction rule of Kirchhoff, so which is like the I1 plus I2 should be equal with I3, which is this here. And from now the rest is just math. I mean, to solve this, first of all, you see that I have three equations with three unknowns, I1, I2, and I3. So that means that this system is can be solved. And of course, if you are familiar with linear algebra, you can use linear algebra to solve this. If not, you can use just simple algebra. And I think in this case it will be faster to use simple algebra. So if you solve this here for I3, you get that, if you solve it for I1, you get that I1 is equal with I3 minus I2. Now, if you multiply equation 1 by 2, 70 minus 60, so that should be 10 times 2 is 20, and here it should be 6I3 plus 4I2. And now you go to the second equation, so you have 20, like 80 minus 60, which is 20, and it's 4, and I1 from here is I3 minus I2 plus 3I3. You work this a little bit, so you get 1 ohm. And now you go to equation 1, and you have 10 has to be equal with 3I3, so that's 3 times the 3.1, so that's 9.3 plus 2I2. So from that you get that I2 is equal with 0.35 ohm. And finally you go here and you go to this equation here, equation number 3, and you have that I1 is equal with I3 minus I2. So that means that if you take the values of I3 and I2 and you substitute it, you get that I1 is 2.75 ohm. So since all the values, they are positive, that means that the direction of the currents that we choose are actually right. So that's the direction of the currents. That's how you solve problems related with Kirchhoff's rules. So thank you for taking the time to view this video, and I hope you find it useful, and bye for now.